Okay, so this is the storage SD card. I'm going to plug this. There is a small so that you can side. The other way. Yeah. So, and we have total 4 USB connector, but one type 2, the other type 2. Two for 2, 2 for 3. And then there's a C type also. C type that is for the power. So I'm going to plug this. This is a C type. Use this. And also there's a switch so that I don't need to automatically on this until I press the button. This is power lines. So I'm going to plug this. And something that I do not have here, okay, is mouse and keyboard. So I have a mouse. This is type 2, and I have keyboard. Very old fashioned, right? This is mouse. This is a keyboard. Okay, wearable keyboard. What I can do, I'm going to display, right? So that I'm going to plug this into the top monitor there. So we have a mini HDMI, one side, and the other regular side that comes with this. And then new type Raspberry Pi 4 has 2. So what the smart refrigerator can embed is this type of small microcontroller. This is called a microcontroller, okay, somehow. So I'm going to plug here one of this. Is there some main or right? This is primary. We have an export, so we are lucky. So I'm going to. I have so many devices that I plug and unplug. Not only that, I have glasses, plug and unplug to my eyes sometimes weak. Oh, the first one is okay. So what I can do.
So this guy needs to.
So what we have. Okay, so we're going to click on this. Not doing this. This is for something else. And then back here, bottom, keyboard, we need to change this to currently GB, right? Raspberry Pi is invented and manufactured in England. So we need to switch this to US. And then this English, let's see, okay, US English. All right, so don't forget that. And then on your upper icons, there's an install. So if you do this, warning, I want you to read, right? You have enough time. But let's click as if we read already. So this is Raspberry Pi, Raspberry, right? Pi comes from where? Why Pi? Raspberry. Okay, whole Pi. Okay. As you look at this, the Debian is currently installed. What is Debian? I'm sorry if you have not heard anything about that Debians. Debian is a naval person, right? Then your car can give you alarm. You can say, "Hey, there is another car," right? That is the first industrial revolution. Second industrial revolution is from electricity. Okay, electric power can move something very fast, very effectively. Therefore, we have trains. Yeah. Based on cyber physical systems. Okay. Why cyber physical? Any plantations, any manufacturers, any workplace, before this fourth industrial revolutions, you guys need to be there physically so that you can start running some, right? Now you don't need to. It started a little bit, some started a little bit earlier, right? For example, under the oceans, there's a cable links. When the internet became really boom in 1990s, there's two technologies available. One through the satellites. For example, US and some countries in Asia, okay? They need to share something through the internet. They can do that through the satellites. Another way is that they can install real cables under the oceans, Pacific Ocean. So which one was installed really? Under the oceans. There's a much faster than satellite communication. Okay? Still satellite communication is the future. But only the problem is the speed. Data rates. We learned data rates, wireless data rates. But landline communications is very stable, very safe, always possible. If there is some errors, detectable. If there is errors, detectable. Communication errors, then detectable. Wireless communications, if there is an error, detection is almost impossible, right? So the idea of wireless communication is to avoid any potential problems. That is the wireless communication. So everything that occurred, that came earlier than this, okay? Fourth industrial revolutions, then we have cyber. Human do not need to be there physically, but still you can operate something over there, okay? This is cyber physical. How come it is possible? Because you can see it as if you are there. What kind of sensors help the guys who can control the manufacturers remotely? First of all, camera, right? So you can see it while you are away. And camera can show you broad picture, but all details can be done by each individual multiple sensitive sensors. Some are air pollution detections or micro dust detections. We don't really care about micro dust here, right? So fourth industrial revolutions, then we can think of all of this. If you look at, from the book, they listed this kind of features. We can list the principles of fourth industrial revolutions here. Interoperabilities. You have one machine here, another machine there. They need to operate, interoperable. Inter means I can use that, they can use mine. It's not just collaborate, interoperable, and virtualizations. some virtualization is also needed. And decentralization. One of decentralized secure technology is called, they said decentralized, but actually it's not decentralized. Blockchain, right? Real-time capabilities, service-oriented, modularity, here, ubiquitous. It is everywhere. Mobile supercomputing. Our phone, for example, very, very powerful. Okay. It's already done, so let's turn it on. This is the first time, so that you can also install your Raspberry Pi in this way. Then you will be able to see, oh, that is computer. Although this guy does not have, it's nothing, right? It's not really a computer. But this is a real computer. This can do much, I mean, computing power is much powerful than, I don't know, our laptop here, but not much different from our laptop. So welcome to Raspberry Pi desktop. Before you start using it, there's a few things to set up. Press next. You can follow, right? Very, very friendly. English guys, is this friendly? Okay, country. Oh, okay. Language. Oh, automatic. Time zone. Let's see what we have. Here, New York. What else? Use English language. Use US keyboard. Use English language keyboard. Both clicked, and then click next button. Setting location. Location means we are in New York. Why this guy ask my location?
Probably for the clock.
For the clock.
Time, right?
Time zone, yes.
Time is important on the Linux systems. It's not really standalone systems. I have my own time, right? You need to communicate with others. Okay, enter new password. 555. If I forget, please help me recall. Oh, if I unclick, then you can see this. Clearly that is it, right? Next. Okay, now we need to select Wi-Fi. Search. Okay, what do we have right now? Mercy Mavericks Wi-Fi. Oh, we have so many. So strong ones here. Oh, why they more? So much better than Type 3. I think this is strong, right? Mavericks Wi-Fi. We can change this at any time, right? In some other course, you know, we set up our own Wi-Fi, right? It's okay. All right, then you may be able to see here, upper right corner. There's a wireless signals. Okay, update the software. Oh, this guy is so friendly. Unless otherwise, you have to do that using Linux command. So he knows that, right? Update the software. You want to update? Yeah, all the time, right? It's better to update. Background picture, much nicer than Type 3. What did you guys say?
It's an arrow.
Error checking for update. This is a network issue, so you frequently updates. The command I'll provide you, so you can do that. Okay. Then we need to restart.
Do you have the Ethernet plug into that?
No, wireless.
That's why
It's still recording. Oh, smart. Why do we need that Raspberry Pi? we need to work on sensors. Okay. So the idea here, let's move. So let's move quick. Impact of industrial revolution 4.0. Service business models may be updated or shifted. Reliability and continuous productivity. Smart buildings, already possible. This building is a smart building. You know that, right? So you don't need a key. If you want to come while this is blocked, then you need to talk to the security guys. Security guys, for example, in Dobbs Ferry, if it is when we meet on Saturday, then you have to call, right? And then they dispatch the security guys. The security guys comes and then they pull up the big chain of the keys. Some security guys forgot which keys. Try all. Here, the monitor, he click button, then this is locked, then unlocked. Okay? And then he also can check if somebody's here. Okay, if nobody's here, then I think automatically the lights off and everything can be off, right? So, sort of. Smart manufacturing. If you join some of the companies, I mean, good size of companies, IT groups, then they have this ERP systems, right? Enterprise resource. Oh, thank you. He's satisfied. So I feel a little bit guilty. Oh, that's your guy. All right. Anyway, ERP. So if you join some companies, then they have multiple sub companies, and then the owner of their companies wants to control them all very nicely. Then they build up ERP. Okay. So one typical ERP system is a SAP, right, or Oracle. So there's a supply chain, smartphones. 2021, 21, next year or this year. What is the population? Population is about 7 billion. How many smartphones? 3.5 billion. Okay. So 50% of the people still uses a smartphone. Pull up this population by ages. Okay. So this red zone is the ages 15 to 59. That age ranges uses technologies, right? Technologies. So anyone here, if you are outside that boundaries, then I do not ask you to learn technologies. Okay, you're free from optional. You can come back here and learn some, right? So you have no excuse. So what I mean by that here is, in that range, 100% is a smartphone. 100%. See here, 2020 somewhere here. This is red zone. So 7 billions. So about 3 billions too old or too young. So about 3.5 billions in that range. They're all 100% have smartphones. Good statistics, right? Okay, here, because this is all installed, so if you click this, then you can see the web browser. Or if you come here, oh, you already have. Welcome to. Let me see if I have the same is there. Okay, here, internet. Currently we have, okay, not much. Only this, right? So it's okay. Let's see. Oh, here. Okay. This is computer, right? And then if you click this, then you can have the command line shell. There you can update. Or you can program. What we can do here, basically, because this is connected to the internet, they are still good, but why they think, oh, we're not good. No, you're good. You're still good. Okay. You may not be good coding itself, but all others, you're okay. So here we're going to work on a little bit of those. There, let me give you one simple example. If you put Python there, Python, let's see what is the version. How can you see the version?
-- version.
Oh, thank you.
Well, you're in the Python REPL now. You have to get out of that.
Yes, sir. That's right. Oh, 2.7. No. Then Python 3. Oh, why oh, we have Python 3. Okay. So I'm going to quit. So what is the version of Python 3? 3.7.3. Not bad, right? 3.7.3. If we want to update, then in Linux, you have to first update and then upgrade. Okay, update first and upgrade. What is the update?
You say sudo, sudo for super do, then you say apt, well space apt for the apt repositories, and then you say update to fetch the updates. And then after.
So what is update? What update can do?
Well, it updates your programs.
Download the repository.
Right, updates the repositories. Your Linux systems has a file that always refer to some repositories whenever the update command comes in. So, for example, Raspberry Pi, Python 3, okay? Then at one time, the repository is place 1. At another time, it may be migrated to another locations. Location means the URL, right? That location needs to be updated. You can manually add if you want. So based on that file, upgrade now possible. Okay. So as Brian, so sudo apt-get update.
You actually don't need the dash get anymore.
Yeah.
It's old school.
Thank you. I'm old.
Yeah.
Also do it all in one shot.
Okay, let it go. Updates can do quick. Upgrade, it may take 30 minutes or sometimes an hour. Do you want me to do that here? It depends, right? How quick I can finish this. Okay. Another thing is here, machine learning. There is another keyword, right? Everybody is talking about machine learning. Machine learning can be much smarter if it takes some data from the sensor, right? Sensor data. Anything that you could do, if it adopts sensor data, then you can produce the better result. Okay, so our iPhone apps developments. So we will start from authentications. Authentication for cybersecurity is very important. That is the first step that you need to make sure, right? Authentication. So we need to practice the authentications. Simply login and password, or two-factor authentication. So we'll do much better than that. Okay, login and password. We can save it here, local. First, we can hard code it on our authentication problem, the program, right? Possible. It's very fast. But if your software is compromised, then you lose everything, right? Therefore, sometimes we need to create another file and save your login name and password, and your authentication program report to that file. So one program is lost, still it relies on open that file and then get the login name and password and check. So you do not lose, right? We need to practice that. Very simple. The other one is what? Login name, local. Password, remote. From the database. Remote to data. So your phone is not connected to the internet. Authentication is not possible. Or you can do, hey, if there is no internet, then okay, use a local. Recently downloaded password can be stored, and that may be used, but not authentication that we're going to do. The other one is authorizations. Authorizations. What it means is that depending upon your role, depending upon who you are, although you are in our system, you can have the privilege to run these systems, but not the other systems. You can touch that data, but not the other data. That type of things is authorization, right? That should be implemented on your mobile phones. It's done. And then machine learning can be applied to your authentication and authorizations. Oh, not yet this. For sensor data. Okay? So think of that. Your creativity may enhance the authentications, because we are in the world where there are lots of sensors deployed. So think of how you can use the sensor. So two modules will be discussed, sensor data and mobile data. So sensor data needs to be collected. So send it to your cell phone or immediately your sensor, or here, Raspberry Pi may have an actuator, right? So actuates some of the alarms. That's possible. Okay, mobile data, mobile apps collects user data. So we need to develop. Actors in sensor data, we have a Raspberry Pi. And sensors. Sensors will be provided. Okay. So you need to buy your own this. What do you need to prepare? Raspberry Pi, at least.
SD card,
SD card, keyboard,
mouse.
mouse, and monitor. You can bring your home TV if you want. Or there's some. Recently, I purchased the portable monitor. It looks like a notepad, or no, tablets, but monitors. It's like tablets, but on monitor only. If you buy it, it can be used not only this Raspberry Pi, but while you are working on your laptop, you may have two screens. Next time I'll show it to you, okay? Because today I brought so many others. For programming purpose, at least one time, as we did, right? You can use this monitor to configure. After you do this, you can set up VNC, right? Virtual network connectivity, C for maybe communication, right? Virtual network communication. That is possible. What I mean by that, after that, then you can use your laptop monitor instead of this. This can display on your laptop.
Will SSH work for what we're doing?
You can say, yeah, right. SSH can be also do. Of course. Where is it?
Raspberry Pi configuration.
That's right. Okay, there's some interface. Then you can disable and enable this VNC and SSH. Right now, those both are disabled. So you can do enable and enable. Those who do not know yet, do not have any experience on Linux, what SSH can do is that you can, this monitor, terminals, through this terminal you are on this Raspberry Pi, right? But you can work on your laptop. Remotely, you can come into this Raspberry Pi. That's what SSH can do. SSH means secure shell. This is a shell, okay? Linux shell. Like Windows. Windows is kind of shell. Windows systems, right? This Windows. This is Unix, is another shell. The shell that we have here, so if you see, right, ls-a, then you can see here bash rc, and that is running when you are on your directory. Okay. So we have a Raspberry Pi sensor. They can be connected physical wiring using jumper cable. By the way, this guy does not have. You need to have a breadboard and then jumper cables. So when you purchase this, make sure that there's a bundles. Make sure there is a Raspberry Pi and breadboard and jumper cables and a little bit of the LED lights to indicate whether your program is running or things like that. That's very fancy, right? Lights, blinkings makes you excited rather than silent movie. Right? So make some colorful LED lights. So if this function is running, then red lights, and the other function is running in some other lights. So very, very fancy and excited. That type of things that I am expected from you. So that things can be done in this Python. Okay, Python. How many lines? Very, very short lines. Believe it or not. Next time I'm going to bring one of the LED lights and blinkings so that you can see. You can get some ideas. Okay. So while we have sensor data, we still have the mobile applications. So we have the Swift. Swift is a very good language. We do not use all the Swift languages here. Swift is the next generation of Objective-C. Objective-C is different types of C++, right? So who liked the most Objective-C? I think Steve Jobs liked it most. And Xcode is, if you download Xcode, then you have a Swift. On your MacBook, if you do not have a MacBook, don't be frustrated. There's another way that you can do. Cloud, okay? Mac in cloud, so-called Mac in cloud, you can use it. Subscription of Mac in cloud, I have a Mac in cloud subscription also, although I have Mac. I think I purchased $20. I don't think I used them all. My subscription was hourly based. I want you to buy monthly so that you don't have to worry about. You do not need to buy now. We're not in that phase yet. First, we will work on this Raspberry Pi, right? Maybe in March and April. If you subscribe 2 months, at least, then you. So by using this, you can emulate your cell phone here, or you can do your watch or your TV. That deployments. Xcode can be downloaded over there. If you are not a member of Apple developers, you can do, but not yet, right? You are not really active developer yet, or will be, right? So right now you can download the Xcode beta versions, okay? Install it on your Mac. The other way that you could do is you can download the VM and purchase Mac OS. Mac OS about $200, right? Then you can run Mac OS all the time on your virtual machines. Virtual machine, because you are the Mercy students, you can download VMware workstation for free. It's about $200-300, right? So download the VMware, and on there, and then you can purchase Mac OS. Then your laptop can run your Mac OS. So first version and second version, right? And the other one is here, Mac in cloud. Mac in cloud. Okay. $1 per hour, $20 per month. On our work, it's too long, right? But they charge hourly. Even if you log in and work 10 minutes, they don't charge you 20 cents, 2 cents, or 20 cents, right? Or 20 minutes, oh, then 33 cents. So eventually, this is what we want to do. Your Raspberry Pi and Python, I'm going to handle this server. Okay, so you can send the data from your here. It's automatically, right? You can set up what I want you to think of what kind of sensor that you want to do. I have multiple sensors, or if you want to buy some other sensors, you can buy. But I have a few sensors available that you can use, but not really sophisticated and interesting sensors there. Only temperature, proximities, or distance sensor, humidities, what else? Very rare, but multiple. So send that data to the server. Because this is automatically, continually sending the data. I do not want you to send big data that may hit up our server, will destroy. So at most, maybe, depending upon your coding, if you want to, in your code, if you want to collect data every 10 milliseconds or every seconds per minutes, then how many data? Collect every second and then send 1 minute. Then how many data? How many sets of data?
60.
60, right? If you set it up 10 milliseconds,
A lot.
6,000, something like that, right? So depending upon your program, here the program. The way that you program in this the sensor technologies is basically opposite to regular coding skills. Regular coding skills, if you have iterations, then always your Python 101 teachers keep asking you, make sure that your program terminates, right? What is the terminate conditions of your iterations? And if you don't keep it, then you will have a negative points, right? Not 0 points, negative points, because that harm your computers. Okay, always your iteration should stop. That is a typical coding guidelines. But in sensor technologies, let it go. That is the sensor technologies. Do not terminate your iterations. So here it uses for loops or while loops. There's no terminations. When your sensor can terminate, where there is no batteries, right? Then it terminates. Therefore, sensor technologies is really important that concerns the power consumptions. Power consumptions is a big hurdles in sensor technologies. So once data built here, then your cell phone receives together with your login credential data and a few other data, and your authentication and authorizations can be determined based upon the data stored remotely here and data received somewhere dynamically. I don't know how, but if you have any good idea, you can implement it. The implementation is not really hard and tough. All technologies here, you simply use it. I think this is it. My lecture.